All right. Well, I hope that everybody had a good weekend. Just to make sure, I've already had several people not aware. This weekend, you get another 3-day weekend. If you guys know about that, you don't have to come to school on Monday because we have content focus sessions. So we get to work, but you get the day off. So yeah, it's awesome. What do we got coming up? Tomorrow, you have your limits and end behavior CFA. All right, remember, if it's a CFA, those are multiple choice. You'll be putting your answers in via the Chromebook. But it's going to be very similar to what we did on Friday, except for the time. We had the rest of the class on Friday to do so. Tomorrow, I'm thinking probably about like an 11-minute time frame. Okay, because you only got 5 questions. It's multiple choice. I mean, there's no actual mathematics to do. It's just your knowledge of the concept. And then we'll put your answers in. I'll walk you all through that again tomorrow. Now, on Thursday, that is a open-ended quiz. It is not CFA. Thursdays is not multiple choice. You're going to do just like we did last week on the homework, which was due Thursday. You're going to go ahead and find me everything from the x and the y-intercepts to the asymptotes, whether horizontal or slant, all that information, and then you're going to use that to sketch the graph for me. That is not a calculator. So I'm thinking on Thursday, probably between 15 and 20 minutes, just to make sure that everybody has that amount of time. Now, something that I've been telling all the classes, last Thursday is when the homework was due, and very, very few people did turn in the homework, and that's fine. Okay. Remember, the homework is practice. It is not taken for a grade, but we got this big quiz coming up on Thursday. You are not allowed to retake unless you've completed and turned in the assignment. Okay, so just kind of throwing that out there. Please don't forget, because if you happen to get low, you might come in one morning and say, okay, I'd like to retake. I'm going to check the grade book. Can't give you a retake. Okay, there's a lot of people who need to do that. So please, if you're one of those folks, just kind of thinking ahead. Now, the big one is going to be next Thursday, the 19th. That's your second exam. So a week from this Thursday. So pretty much the majority of it expected to be over rational functions, rational inequalities and equations, all that good stuff. Might even go ahead and spiral an old concept in there. So, but primarily it'll be over everything from the previous exam. All right, let's see, what else do we got? Wednesday, what's happening during second period? You have your next drill. Okay, you got your next fire drill coming up on Wednesday during second period. So if we were to have a fire drill in here, remember, we go straight down the stairs, leaving all your material in here, of course, down the stairs past the nurse's office to the sidewalk on 19th Street. But then where do we go? We go over to the east parking lot where the band practices after school. Okay, and be looking for me if that should ever occur, because then I'll have out my phone on the Navigate app. I'll be taking the roll, okay, to make sure that everybody made it out okay. The only other thing you'll notice, something brand new on your desks. These are what I call your villain buddies. So if I ever need to get you guys into groups like very quickly, I can go ahead and say these villains get together. Or if we happen to just be working on a problem in class and you want to kind of bounce ideas off each other or check your answers, I'll probably go ahead and make reference, check with your villain buddy. Okay, so very quickly, is there anybody sitting at a desk that you don't know who your villain is? Okay. Emma does not know. Let me take a look. That is Ra's al Ghul. He's the demon head. Okay. His daughter had a son with Batman. Kate, that's the Riddler. Okay. Oh, there's a lot of hands going up in this class. Okay. That is Bane. Let's see. Yours is Bane. That's the Scarecrow. Okay. That's Mr. Freeze. Mr. Freeze. Anybody else? All right, so you should notice people around you in sets of 3 are going to have the same villain. That's who your villain buddy is. That's Two-Face. That's Two-Face. District Attorney Harvey Dent got acid thrown in his face by Boss Maroney at a trial, and he went insane. All right, so good. So those are on your desks, okay? If you have a question, let me know. All right, well, why don't we go ahead and get started? We'll see how far we get today, and then, we'll just make it through the week, get to a 3-day weekend. All right, so the graph of the rational function g is already graphed here. Now, This lesson is going to be broken up into two parts. We're going to be looking at rational equations, and we're going to be looking at rational inequalities. I definitely want to spend the majority of our time on rational inequalities and not so much on the equations, but I am going to go ahead and kind of review you on that. So when you're solving an equation algebraically, when you combine your like terms, when you isolate the variable, well, really what you're doing is graphically you're comparing the two functions, and you'd be looking for the intersection of the two. Like if I were to take this rational function right here, x squared plus 4x plus 3 over x squared plus 2x minus 3. Let's say I wanted to create a rational equation by setting this guy equal to 3, just a numerical value. Okay, well, I see the graph of the rational right here. Well, what kind of graph would 3 give me? Well, it's not vertical, it's horizontal. It's just a horizontal line, right? So if I were to go ahead and draw a horizontal line at y equals 3, well, the answer to this would be wherever they intersect. So it looks like I should be getting an answer of 2, right? So graphically, it's really easy. But algebraically, we should be getting the exact same answer. Remember, I just made this up. I just set it equal to some number. Okay, so why don't we go ahead and solve this? Let's see if we actually do get 2. X squared plus 4x plus 3 over x squared plus 2x, bless you, minus 3 is equal to 3. Now, the nice thing about rational equations, there are a lot of different strategies for solving these. I want to find the value or values of x that make this a true statement. Okay, so one strategy that a lot of people like is to go ahead and multiply the entire equation by the common denominator. Well, here there's only one denominator because there's one fraction. So I'm just going to multiply by x squared plus 2x minus 3. I'm going to multiply through by that trinomial. Because if I multiply this trinomial by that fraction, what happens? What's that, Philip? No. Let's say if I were to have a fraction, like if I had, I don't know, something like 5/7, and I multiplied that fraction by its denominator, well, what are they going to do to each other? They're going to cancel, right? That's what we're hoping to do here. We want to remove all the fractions so that we can get a mainstream equation. So these two trinomials are going to cancel. That's going to leave me x squared plus 4x plus 3 equals. Now, we want to be careful. I got to multiply that denominator by everything. So here I've got to triple it. So what would I get if I tripled that trinomial? 3x squared plus 6x minus 9. See, no fractions. We can combine our like terms and end up with some kind of resulting equation. In fact, it's going to turn out to be quadratic. Now, you can move any terms you like, okay, as we've seen before. Personally, I like to make sure the x squared is positive, especially if I'm going to factor. So if I subtracted the x squared over, how many x squareds would that leave me? 2x squareds. Okay. What if I subtracted the 4x over? Plus 2x. And then if I subtracted the 3, minus 12. So here we now have the standard form of a quadratic, something we're very used to solving. Okay, and whatever method you prefer, again, I've been pushing factoring lately, quadratic formula, completing the square, completely up to you. But does anybody notice anything? There is a GCF. Now, here's the thing. It's not like we were factoring. I don't have to keep the common factor there, which is 2. I can just actually divide him out. That would be x squared plus x minus 6. Now, it's true, this is a different graph than the one we just had, but they'll both have the same roots. And that's all we're interested in. Where do these guys cross the x-axis? Okay. So what would the factored version of this be? Okay, so I'd have a plus 3 and then a negative 2. Would everybody agree? Okay. And then how do I use that to get my answers? Yeah, set them equal to 0, my zero product property. So if x plus 3 equals 0, I have x equals negative 3. If x minus 2 equals 0, well, then I got x equals 2. Did anybody notice anything? You remember when I did this graphically, when I drew the line y equals 3, how many points of intersection did I have? I had 1, and it actually turned out to be 2. So we got the 2. That's correct. Where did that -3 come from? Does anybody remember what we call him? Long word starts with an E. Does the term extraneous sound familiar? What that means mathematically is a false solution. Okay. Now, in the process of solving this equation, we ended up with a quadratic. Now, it's true the roots of this quadratic are both -3 and 2. But are they both answers to the original equation? That's what you have to check. If you were to plug -3 back in here, it is not going to equal 3. Okay, so it's very likely you could end up with a false solution. So it's always a good idea to plug those back in and see if that's what happens. Okay, remember that's what we call extraneous. So that doesn't sound familiar? That was not covered in Algebra 2? Really?
We talked about false functions, but we didn't hear about it.
Really? Okay, okay. All right, well, let's try another one. Let's try another one. I'll show you another strategy. Okay, and then we're going to go ahead and move on to the inequalities because that's what we really want to do. Let's see here. What was the other problem I chose? I've got 1/6b squared plus 1/6b equals 1/b squared. So this one is not related to the problem on your paper as the previous one was. This is just a completely different rational equation. I want to find the value or values of b that would make this true. Now we could go ahead and multiply through by the common denominator like we did a moment ago, or I could go ahead and rewrite every fraction so that it has the same denominator. Can anybody tell me, what do you think the common denominator would be for this expression? It would be 6b squared, yes. So this first one, 6b squared, I'm not going to touch it. But 6b, I'm missing a b over b. And see, what is b divided by b? 1. See, I'm not changing his value, I'm just changing the way he looks. Anything times 1 is still himself, right? What am I missing over here? There you go. So now multiply those together. 1/6b squared, or I guess 2b or not 2b. Okay. b/6b squared. I mean, it's not English, but it's going to be literature. Okay, moving on. Once again, Mr. West bringing the house down. Okay. All right. So would you agree all 3 of those have the same denominator? If that's the case, you can basically cut those loose. Your equation is just the numerators. So I can say from this that 1 plus b would equal 6. So b equals what? 5. Okay. So a lot of different ways to solve these guys. Okay. It just depends on what your strengths are when it comes to, your algebra skills. Now again, ideally, you would go ahead and plug this 5 back in to ensure that it is a solution. Is it possible that you get one answer that could turn out to be extraneous? It's very possible there might not be a solution at all to your equation. You always want to check. Okay. Now, I'm going to go ahead and give you one more, but we're not going to solve it together. Okay, let's try this one. N plus 5 over n plus 8 is equal to 1 plus 6 over n plus 1. Okay. Now, what I'd like for you to do sometime between now and the start of class tomorrow, take a few minutes. Again, it's not going to take a lot of time. Okay. Solve this equation. Find all the values of n that would make this true. And remember, there are going to be other strategies for solving these that I didn't talk about. Pretty much I focused on the common denominator. Now, if this is something that you don't quite remember, or you're thinking, what, I need a little extra practice, if you go to the website, okay, If you go ahead and take a look at the website, see here's the week of 9/9 to 9/13, everything that's happening. Here's the rational inequalities and equations and notes that we're talking about. But solving rational equations, I've got a whole worksheet here with a ton of rational equations. Now the answers are at the end. Okay, so again, if that's something that's going to interest you, it is available. Okay. But remember, you are going to be responsible for that material. So please come in if you have questions. Has everybody got that copy? Okay. All right. Well, now we're going to put the equations to the side. Let's get to the main focus of our lesson. Let's talk about the inequalities. So you remember about a week or so ago, I said that we were going to start seeing expressions like these, where you had f of x was greater than 0, f of x was less than 0. Okay. Well, let me ask you a question. What kind of values are greater than 0? Positives. Positive numbers are greater than 0, right? So what kind of numbers are less than 0? Negatives. But when you're comparing f of x to 0, that means you're comparing the graph to 0. So 0 is represented by the x-axis, okay? Because that's where y equals 0, right? So any portion of the graph that's above the x-axis is considered above 0. That's going to be positive. So let me go ahead and highlight this. So this region right here, along with this region right here, that's where the function is positive because those exist above the x-axis. Okay. So where it's less than 0 or negative, well, that's the only places where they're below. That's what we're talking about. When we compare it to 0, literally, where are we above or below the x-axis? Is everybody okay with that? Okay. Well, let's take a look at these 5 questions given this graph. Now, the first one is not an inequality. Okay. All it says is, where is g, this graph, equal to 0? So wherever this occurs, what do we actually call that when the graph touches the x-axis? Yeah, that's exactly what we're looking for. When you set the function equal to 0, we want to know where it touches the x-axis. What's the x-intercept or intercepts? Okay, well here there's only one place where it crosses. What's that value? -1. So x equals -1. So just like we did a moment ago, when I set that equal to 3, if I were to set that guy equal to 0 and solve, we should be getting -1. Okay? We just solved the rational equation. We're just using the graph. Now, numbers 2 through 5, these are my inequalities. All right? So number 2, where is function g greater than 0? So what am I interested in here? Positive or negative, above or below? Positive. We want to know where is he above the x-axis. Well, remember, that's everything that I highlighted in green. So somebody give me this left portion in interval notation. Okay. How far left will it go? So it's going from negative infinity to what? Now, why do we have to stop at -3? Remember, that's a whole. Okay, so -3, union. Now, -3 to what? -1. And here's a good question. Should I put a parentheses or a bracket on that -1? Heard of parentheses, I heard of bracket. Okay. There you go. Look at what the inequality wants. He says greater than. He doesn't have equality, so anything touching the x-axis can't be included. It's little things like that, that can cause some mistakes. Now, we're still not done. Is there any other place where he's above the x-axis or greater than 0? Yeah, from 1 to infinity, from the vertical asymptote forever. Okay. Now, what about number 3? Where is function g less than 0? Well, where's the only interval telling me where he's below the x-axis? Between what and what? I'd say between -1 and 1, because he's going to get close to that asymptote, but remember, he won't ever touch. So -1 and 1. Now, we won't include the 1 because he is a vertical asymptote. Again, what about that -1? What do you think? Parentheses or bracket? parentheses because it wants less than. It's not equal to. Now, if it was equal to 0, we'd go ahead and put the bracket. Is everybody okay with how I'm doing this? Remember, where it's greater than 0, that's positive above the x-axis. Less than 0, that's your negative where it's below. Well, do you notice anything about numbers 4 and 5? The only difference is we now have equality. So these answers are going to be very nearly identical. In fact, how would I rewrite number 2 to get the answer for 4? What's the one change? Bracket on what? There you go. Everything would be the same, except when I get to that -1, I would have a bracket because we have equality. And then union 1 to infinity. Okay. And the same thing is going to apply for number 5. Number 3 was strictly less than. Number 5 is less than or equal to. So this should be bracket -1 to 1. Okay. So we're listing the values of x in interval notation where the graph is above the x-axis, positive, or where it's below the x-axis, where it's negative. And that's what this whole lesson is about, making that connection between what we're doing by hand, seeing that it's telling you what's happening graphically, even if we don't see the graph. Okay. Well, let's move on. Given this function g, so for a while, we're going to stick with this guy. We're going to be spending a lot of time with him today. Find the values, g of -3 and g of 1. What does it want me to do? There you go. Remember, that's function notation. Whatever's in the parentheses, I'm going to replace every x. Okay, so g of -3. Let's see here. That would be -3 squared plus 4x, 4 times -3 plus 3, over x squared, so I got another -3 squared, plus 2x, so plus 2 times -3, minus 3. Okay, because if you're looking at the graph, I mean, something is happening at -3 and 1, and there's a reason for it. Okay. In fact, can anybody tell me what's the numerator become?
0.
Yeah. Looks like we have 9 minus 12 plus 3, so that's 0, over 9 minus 6 minus 3, that's also another 0. Now, it's true, 0 divided by anything is 0. But there's one exception. You can never divide by what? You can never divide by 0. So that means it's undefined. And typically for undefined, I go ahead and use that little no solution symbol. Okay. So if I know that the function is undefined at this value, that's telling me there's some kind of discontinuity there. Okay. We can already tell whether it's a whole or a vertical asymptote. All right. Let's do the same thing for 1. G of 1. Okay. So 1 squared plus 4 times 1 plus 3 over 1 squared plus 2 times 1 minus 3. Okay. Well, 1 plus 4 plus 3. 8 over 1 plus 2 minus 3. 0. So at this location, 1, it's undefined as well. And again, this is what we were talking about last week. Okay, we would be able to tell, well, is that 1 now a vertical asymptote or is it a whole? I mean, graphically, we can already tell it's the vertical asymptote. Okay, but why is this happening? Well, these are the values of x that make what 0? The reason we got undefined is because they make the denominator 0. Those are my undefineds. Any value of x that makes the denominator 0, those become your discontinuities, whether it's a whole or a vertical asymptote. Okay. So let's go ahead and factor this function here. Okay. Pretty simple trinomials. I'll do it down here. G of x equals. Somebody factor the top for me. X plus 3, x plus 1. Okay. Over the denominator. X plus 3, x minus 1. Okay. Now you can tell right off what we already knew One of these values was a whole because a group canceled. Remember, only if a term or a group factor cancels will there be a whole. Okay. So it says identify the value or values of x that make the function equal to 0 and the value or values of x that make the function undefined. Well, you remember at the very top of the page when we did number 1? Where we were looking for where the function is equal to 0, we were really looking for what intercept? We were looking for the x-intercept, right? If you go back to the beginning, okay, if we were setting this guy equal to 0, we were wanting to know where he crosses the x-axis. Okay. Well, do you guys remember the shortcut from last week? What do I set equal to 0 if I want the x-intercepts? Remember, it was the numerator. Well, the only thing left in the numerator after the cancellation is this x plus 1. So if x plus 1 equals 0, well, x equals -1, my one and only x-intercept. In fact, would anybody like me to show you why the shortcut is to always set the numerator equal to 0? Would anybody like to see that? Andrew, did you raise your hand, or did you? Will, are you raising your hand, or are you just holding your pen? Okay, we got one person who says yes. Okay. So let's say I took the actual function. Let me do this down here. Oh, what was it? X squared plus 4x plus 3 over x squared plus 2x minus 3. Well, let's say I did set him equal to 0. Think about how we solved that very first rational equation I gave you. I just multiplied through by the trinomial denominator, x squared plus 2x minus 3. Okay. What's going to happen if I multiply this trinomial times that fraction? Those denominators will cancel, leaving me x squared plus 4x plus 3, which is the numerator. And then we don't want to forget 0 times that trinomial as well. But what's that? 0. So see, all you really did was just set the numerator equal to 0. Okay, that's why we have that particular shortcut. Okay, let me take this off right here. Now the other one, okay, g of x is undefined. Well, the values that make it undefined, those mean the values of x that make the denominator 0. Okay, so I've got two groups, even though one of them canceled. X plus 3 equals 0, x minus 1 equals 0, x equals -3, and x equals 1. Okay. Now, why was -3 a whole and not the vertical asymptote again? I keep forgetting. What's that, Connor? There you go. Because that -3 belonged to a group that canceled. See, x minus 1 didn't cancel, so that means 1 has to be a vertical asymptote. Okay. So we have one value, which makes the entire fraction 0. We have two values, which makes the entire fraction or function undefined. We'd be forced to divide by 0. Okay, so what does all this mean? I'm glad you asked. Okay. I'm going to show you now what a sign chart is. Okay. So this paper is set up. You've got everything labeled for you, steps exactly what to do, so that if you ever forget what we talk about in class, you can just go back and see exactly what your notes say. I mean, basically you want to do that every time, but this is actually listing the steps. The only thing I want to highlight in number 2, it says draw a number line that's divided into segments using the zeros. That number line is what we call a sign chart. A sign chart is what we're going to use to solve rational inequalities. Okay, so you'll notice we're still looking at function g. This is the exact same function that we've been looking at on the previous page. I want to know where is he less than or equal to 0. But now the graph is gone. We're doing this by hand. Now, even though step number 1 says to go ahead and factor, I'm going to go ahead and tell you there's always a better step before you begin that. Make sure you're comparing your function, your fraction to 0. You've got to get everything to one side. Whether it's less than or greater than 0, you always have to start the problem with that happening. Okay, then you can begin the process. Okay, well, number 1 says to factor. Well, we already did that. So I'm just going to write it again. X plus 3, x plus 1, over x plus 3, x minus 1, and this was less than or equal to 0, right? Okay. Well, from the previous page, we got 3 values that were of interest to us. One value made the function 0. What was that? -1. So we got -1. And there were two values that made the function undefined. What were they? They were -3 and 1. Well, when we're going to go ahead and create my sign chart, remember it's just a line graph, okay? Just like a good old line graph you made way back in Algebra 1 and before, okay? But these values, the discontinuities and the 0, that's what I'm going to put on my line graph. Of course, we want to put them in order. So I'm going to say -3, then we have -1, and then we got a 1, okay? Now, the sign chart, this line graph, that's your work. That's what's going to help you get your answer to the problem. Okay? So we want to be able to label for anybody who looks at our work to be able to say, okay, I know that -3 is either a 0 or a discontinuity. All right? So any value that comes out of the numerator, we're going to call him a 0. He's an x-intercept. Any value that comes out of the denominator, he's my undefined value. Okay? So the one value that came out of the numerator was -1. So he's my 0. I'm going to put a 0 right above the line graph. Okay? Both 1 and -3, they came out of the denominators. So I'm going to put my no solution symbol. Those are undefined. Now remember, we already know what the graph looks like, but the hope is that somebody who doesn't have a mathematical background would look at your paper and be able to understand what it is that you're trying to tell them. Okay, I know this -1 has a 0 above it. That's got to be the x-intercept. I know that -3 and 1, he's telling me that that forces me to divide by 0. So there's some kind of discontinuity going on at those values. That's what we're trying to communicate here. Okay. Now there's a little more information that needs to go on to fill it in completely. In the top right corner, you always put the original problem that you're solving. Okay, so I'm going to say x squared plus 4x plus 3 over x squared plus 2x minus 3 less than or equal to 0. And then in the bottom right corner, you go ahead and put the variable x, because these values of x are very important to the graph. Okay. Well, there's only one other thing we need to put on the sign chart, and we should be able to start getting our answer. These values, would you say they're going to have an open or closed circles? Okay. Okay. Why closed? Because we have less than or equal to, right? But here, watch what I'm going to do. I'm going to include the -1. I will not include the -3 or the 1. Why did I do that? Will? That's exactly right. Even if the problem says it has equality, you can never include the values of x that make the denominator 0. Okay, what's the one thing you can never divide by? 0. So there's no way you can include those in your answer. You can't divide by 0, so the undefined values will never be included. They'll always have an open circle on them. Okay. Now, you remember what we did last week when we were looking at the behavior of a vertical asymptote? We had our limit statements, and we were just looking at the signs, positive or negative. That's exactly what we're going to go ahead and do here. You've got 1, 2, 3, 4 regions created by your 3 numbers here. I need to figure out, are they positive or are they negative? So we need to choose a value. Okay. So somebody give me a number less than -3. -4. And what I like to do is I like to write the number in that interval, just so when I go back I can tell what number I chose if there was ever a mistake made. Okay. Now we don't want to choose these numbers themselves, the -3 and the -1 and the 1. We already know what happens there. Okay. So we just want to choose a value in the interval. Okay. So I'm going to take this number of my choosing and I'm going to plug it in for each of the x's. Now I'm not interested in the final number. I just want to know ultimately positive or negative. Okay, so what's a -4 plus 3? That's a -1, so negative, right? Just like we did last week, I'm going to mimic the groups with signs here. So now what's a -4 plus 1? That's another negative. -4 plus 3 is again a negative. What about -4 minus 1? That's another negative. So 2 negatives divided by 2 negatives, ultimately what would that give me? That's a positive. So this is a positive interval. See, that's why we call it a sign chart. I'm only interested in a positive or a negative symbol. Is everybody okay how I did that? Is anybody lost? Okay. Sandra, I need a number between -3 and -1. -2. Perfect. And I'm going to do the same thing. Okay. There's my division bar. -2 plus 3, positive. -2 plus 1, negative. -2 plus 3 is another positive. And then -2 minus 1, that's a negative. Again, I have two symbols above, two below, just like my factored version. I'm just recreating it here with signs. What would this one be? Okay, a negative over a negative is a positive. Okay. Everybody still with me? Okay. Jordan? That Jordan, sorry. I need something between -1 and 1. 0. Okay. We'll do the same thing. 0 plus 3, positive. 0 plus 1, positive. 0 plus 3, 0 minus 1. So this is our first region that's what? Negative. A positive divided by a negative, that is a negative interval, a negative region. Okay. And we've got 1 left. Adrian, I just need something bigger than 1. 2. Perfect. Okay. And we're going to plug it in one more time. So let's see. 2 plus 3. Positive. 2 plus 1. 2 plus 3, another positive. And what about 2 minus 1? Positive. So what's this last interval? It's got to be a positive. Okay. Now, you remember I said at the very beginning, even though it says step number 1, go ahead and factor, I really said you wanted to do what first? Always compare your rational function to 0. That's going to tell you what my solutions are now. You'll notice the original problem said less than 0. What kind of numbers are less than 0? Negatives. So I am only interested in the intervals where I got a negative. And in fact, there's only one. Only between -1 and 1 do I have a negative. So now remember, this is your work. The sign chart is just your work. Okay, my final answer would be to write that in interval notation. This is what number 4 is talking about. So what would this be if I wrote it in interval notation? Okay, bracket, because it starts with a closed circle. -1 to what? 1. Parentheses, because the 1 is not included. This is where this function is less than or equal to 0. Now you want to see something really cool? And you're probably thinking to yourself, wow, even more cool, Mr. West? I don't think I could handle that. Exactly. Okay. So let me show you. Okay. Look at these values that we had here on my line graph. -3, -1, 1. Let me look at this graph again. See, here's -3. Here's -1. Here's 1. Look at your signs now. Positive, positive, negative, positive. Okay. Well, from -3 and under, it was positive. Between -3 and 1, positive. Between -1 and 1, it was negative. From 1 to infinity, it was positive. What is this sign chart telling me? It's telling me where the intervals exist that the graph does what? Like, why is it positive less than -3? Where's the graph? It's above the x-axis. It's positive. Where is the graph between -3 and -1? It's above the x-axis. That's why we got a positive there. Where is the graph between -1 and 1? It's below. That's the only place we got a negative. See, the sign chart is trying to tell you what's happening graphically, even if we don't see the graph. Okay. How many people have seen a sign chart before? A few folks. Did they teach that in Algebra 2? Not familiar. Okay. Is it making sense? That's what I want to go ahead and focus on this week. Now, this one took quite a bit of time because I really wanted to make sure you have the connection between what we're doing by hand and what's happening in the graph. What we're going to go ahead and do starting tomorrow, we're just looking at these problems. We're not going to go through the entire process that we just did. Okay. So, a couple things very quickly. This one sheet that you picked up, remember tomorrow your CFA quiz is over what? Limits and end behavior. This is just more practice right here. In fact, what I'm going to do, bless you, during my conference period 4th, I'm going to go ahead post the answers to this to the website. If anybody wants to check their answers, later on during the day. If you want to come in during tutorials, I will be here in the morning. Okay. The other one, that's the assignment for this particular lesson. I don't know if we're going to have that due Thursday or Friday. For right now, let's go ahead and say Friday. Let's say Friday to be on the safe side. Homework due Friday. Okay, so this is going to allow me